Hi all, in this one we're going to take a look at some of the magic behind variable substitution in equations. Please note that this is not a standard video, there are a lot of those already. I'm not going to show you just how to solve using variable substitution. I want to show you some of the graphical underpinning behind it that's kind of fascinating. So let's take a look here. Imagine that we want to solve an equation that looks like this one. X plus 1 squared minus 5x plus 1 and then plus 6 equals 0. Let's look at this equation. This is a quadratic equation. It's true that on the left side, you could FOIL this out, distribute the negative 5, gather all the terms, and then get a new quadratic equation and try to solve that. That's all very true. I'm going to use the variable substitution instead because it's perhaps a bit more elegant. So what do I mean? Let's say that I'm going to recognize a key fact. A key fact that I can recognize is that this piece is the same as this piece. What does that tell me? It tells me that variable substitution is a potential step forward because I have two things that repeat. So I can arbitrarily, that's true, define as U or P or Z. Use whatever letter you want. That's not important. You can call it Bob if you want. So U equals X plus 1. That allows me to rewrite this equation in a simplified form as simply u squared minus 5u plus 6 equals 0. I think you will agree just by examining the equation in step 3 that it definitely looks simpler than the one in step 1. So what, you ask? Now we would factor and all of that. I'm gonna do this and take a look down the graphical rabbit hole of mathematics to see what all of this means. So let's proceed. I'm going to show you as follows. This is going to be my x-axis. So the x-axis in this graph is going to come straight down to here. This is x. I'm going to put a u-axis, and how do I know I need a u-axis? Because if I look at this, you see x is a variable on this side and then u is on this side. And clearly at step 3 we have a variable u, basically in the first two terms. So let's write this down this way. This is going to be the u-axis in this context. And let's mark off some spacing. We want to be able to fit everything very clearly. So along u, say 3 spaces will be a 1. So another 3 spaces here would be a 2. Another 3 spaces would be a 3. Another 3 spaces would be a 4. Just to space things out so they're big and easy to see. Same thing down the vertical axis, 3 spaces. That's a 1. That's a 2. That's a 3. Yeah, let's do one more here. So that there would be a 4. Let's zoom back out. How do we graph this part of it? This is kind of interesting. So u equals x plus 1. We want to show that in our little graph. Well, go back to the basics of graphing. So graphing u equals x plus 1. I'm going to call this step 4. I just choose a couple of values. So for example, when x has the value 0, I'm going to get u equals 0 plus 1, which is 1. So let's mark that over here. That would be this point. And here I have to be really careful about the right size of things. It's pretty good. It's going to be this point. So this is u equals 1. The one I've just marked right here. U equals 1. Let's do one more of these. Go back. What happens, for example, when x has the value 3? So you graph u equals 3 plus 1, which is 4. That's the value of u. So you mark that over here. So you go over to x equals 3, u equals 4. Let me grab this, make it a bit thicker. There we are. So at 3, 4, I mark another point. That's that. And now I can just connect these with a straight line. Because after all, look at it. It says u equals x plus 1. That's linear. X is to the first. It's a linear equation. That means when you graph it, it's a straight line. So let's do that. I'm going to graph that over here. To be really careful at this point. Make sure everything is just so. That kind of looks like this. Perfect. And now let's ask ourselves the next question. This represents u equals x plus 1. We have this equation that we are going to solve in u space just because it's easier to solve. So let's do that down below in this little space. So I have u squared minus 5u plus 6 equals 0. So after that, just factor both sides, well, factor the left side, to be clear. It's going to give me u, what is that? Minus 3 and then u minus 2. Negative 3 times negative 2, 6. Negative 3 plus negative 2, negative 5, it checks. Then you set each one equal to 0. So u equals 3, u equals 2. Those are the solutions in u space. Let's graph those solutions in u space. Those solutions are 2 and 3. I want to make sure, 2 and 3, good. So these are the solutions in u space. Let me emphasize these right here. You take, so 2 is one of those solutions, and then 3 is the other solution in u space. Can we just stop here though? Well, obviously we can't. Why not? Because, look, our original equation was in terms of x plus 1 squared minus 5x plus 1 plus 6 equals 0. We solved the simplified equation u squared minus 5u plus 6 equals 0. So we now have to use step 2 that says u equals x plus 1 to get back from u space to x space. What I mean by those is we have to take the value that solves the equation 3 and get it back to a value in x. So here we're going to do this in a graphical way. That's why I need that slanted line that you see there, because that's the key. Let me grab a little arrow so we can trace our work carefully. So this is going to map back over here. See how beautifully that works? So this is x equals 1. That tells you that x equals 1 solves the original equation in x space, where the x space is just really the x-axis, a fancy way of talking about x values. So that's this one. And then here, let's map this one back. So when I map this one back, it's going to look like this and then this. And as you can see, this maps back to x equals 2. I think this is absolutely fascinating how connections can be formed in mathematics between different variable spaces. But let's also be honest with ourselves. So it is true that solving u squared minus 5u plus 6 equals 0 is easier because it's easier to factor that. But then that step number 2, u equals x plus 1, that introduces a whole new world that we have to then understand, obviously. And I personally find it fascinating. I've been thinking about this for a while. You should know another thing, that in this diagram, when you are going from x over to u, remember that in this context this is the u-axis, when you are going from x space over to u space, u equals x plus 1. So from x over to u. But if you want to go from u over to x, you gotta solve that equation. In other words, you have to write u minus 1 equals x. That is what maps us back from u space to x space. Because now this part says begin back on the u-axis, where you solved u squared minus 5u plus 6, stick in the solution into u and get the corresponding x out. Get the next solution to this equation in u space, stick it in here, and get the corresponding x out. So when I did that just now, by drawing the arrows over here from the 2 over to the 1, I was using this. When I drew the arrow going from here this way, I was using this equation, that relationship between x and u, the inverse one if you like. I've shown you a relatively simple example compared to what's possible, obviously, but it is kind of fascinating. So I hope it's shown you something unique, stirred your imagination to think in new dimensions and directions. To me, after doing mathematics for a number of years, when I look at conventionally written books, my eyes glaze over, and I say to myself, I bet you there's a whole world hidden here. How can I find that little world for myself? And what can I discover in that world in terms of real understanding? Thank you so much for watching. I'll see you in another video. Please leave a like, it all makes a difference. I appreciate the fact that you've spent some time here exploring with me.